Good morning, everyone. I am Sudheer Kumar Aluvala. It's happy to be part of Conf42 Machine Learning 2026 conference. Today, we are going to explore a critical evolution in the world of cybersecurity. The topic which I chose is machine learning-driven complaints engines for zero trust security. As we navigate the complex landscape of 2026 and the sheer volume of the data and the speed of modern attacks have fundamentally outpaced human-managed security. We are here to discuss a paradigm shift which is transforming static policy enforcement into an intelligent, adaptive security controls. This isn't just an automation, it is about building a defense system that thinks, learns, and reacts autonomously at the same velocity as the adversaries we face. Before getting into the topic more, I would like to have a quick intro of myself. Currently, I'm working as a client delivery director at HCL America. And with this role, we are primarily providing ZTNA frameworks and the AI-driven compliance solutions for multiple enterprises and also SMB customers. Few of them are part of Fortune 500 organizations. The insights which I'm sharing today are primarily coming from the challenges which we faced while implementing our solutions in high-stakes environments where static is synonymous with vulnerable. Let's get into the topic itself. While we are trying to implement these solutions, primarily it's a gap of the compliance gap in zero trust itself. While many organizations have implemented a zero trust network security protocols and access, they are still tethering this modern architecture to a legacy mindset. Currently, many of these organizations rely on static, manually defined policies that simply cannot keep the pace with the rapid evolution of modern threats. These traditional rule-based controls struggle to adapt a new attack patterns and fail to scale across hybrid and multi-cloud environments that define our businesses today. Let's deep dive into why this status quo is failing us. Because many of the organizations have defined their policy enhancements or upgrades or updates is very periodical. This traditional policy refresh on fixed schedules, often leaving security gaps between update cycles while threats evolve continuously. And the second thing, what I found is the manual configuration risk itself. The human-defined rules are primarily prone to misconfigurations or inconsistencies and simple errors that create exploitable vulnerabilities. The third one, which we've seen, is that scalability barriers. As digital footprint is kept on expanding, maintaining thousands of individual rules, whether it's individuals or whether it's for groups within the organizations, or fragmented systems are becoming operationally unsustainable. So these are the three key pillars in terms of the issues which we can categorize while implementing these solutions. Let's move on what exactly the solution which we are looking currently. Our solution is a transition to a machine learning driven compliance framework. We are moving away from very rigid rule-based logic and towards intelligent models. So these models are capable of learning, adapting, and enforcing compliance in real time directly with ZTNA ecosystem. We are essentially replacing the manual bottleneck with an intelligent and self-governing engine. So if you see the architectural overview, so it's a closed loop design. It functions across four critical repeating stages. One is the first step is the data ingestion. This is the sensory layer gathering the telemetry from across the enterprise. And the second pillar is the model training, where the engine turns the raw data into an actionable intelligence. The third one is predictive enforcement based on the data which got through the ingestion layer and the model training layer. This is a proactive layer which makes and access decisions based on the projected risk. The fourth one is the automated feedback. This primarily ensures the system learns every outcome and create a self-optimizing control layer. So with these four layers where we are currently looking at predictive enforcement and automated feedback, we can ensure we can avoid the delays and then secure the organizations. So if you see the source of powering these decisions, or primarily if you see that the engine pulls the data from three primary pillars. One is endpoint telemetry, which provides the real-time data on the device health configuration, states, and the patch levels. And the second is the user behavioral analysis itself, from which we can analyze and access the pattern and authentication history to generate the contextual risk score for the individuals. The third one is the cloud native threat intel, where we integrate global threat feeds and industry specific vulnerability intelligence data to stay ahead of emerging attack vectors. By synthesizing these data points, we enable a dynamic risk assessment model. We no longer rely on snapshots in time. The system evaluates risk based on current conditions. If threat indicators change, access decisions are just on real time. And furthermore, predictive analytics allows us to identify potential compliance violations before they occur, moving us from a reactive defense to a proactive posture management. So while deploying these production solutions, these ML-based solutions, what we found is there is an achievement of 40% faster incident response through automated enforcements, and also 98% of reduction in critical policy errors through ML-generated controls, and there is a 60% decrease in manual effort, allowing team to pivot into the new strategic initiatives rather spending on mundane daily tasks. So the continuous learning feedback loop, this is primarily the brain of the system, is the self-improving intelligence itself. Every enforcement decision becomes a training data. The system learns from both successful interventions and false positives, continuously refining its accuracy. This closed loop approach ensures the framework evolves alongside the environment and emerging threats. Next is the enterprise considerations for this framework likely to be succeed. It must have explainability and governance. Enterprise adoption requires trust. So we provide a clear decision rationale and complete audit trails. This ensures that even though the engine is automated, it remains transparent and meets all regulatory requirements. The security must also be ethical. The bias detection and mitigation should be avoided because it ensures the access decisions remain non-discriminatory. Human oversight, which is required sometimes, security teams should have a supervisory control with the ability to review and override the decisions. Privacy and preserving the analytics, which are primarily respecting user privacy through anonymization and the purpose limited only to the data processing. Deployment flexibility, what we have done is we have designed this for SMBs. We have considered as a lightweight deployment with managed ML services for rapid time to value. For large enterprises, primarily we support hybrid deployments and integration with existing SIEM and SOAR platforms as well. The future of the zero trust compliance is, in conclusion, what I would like to say is machine learning transforms compliance from a static checkpoint into an intelligent self-learning control layer. This represents the vital shift from reactive policy enforcement to proactive intelligence-driven security. Thank you for your time. My name is Sudheer Kumar Aluvala, and it's been a privilege to share this vision at Conf42 Machine Learning 2026. Thanks, everyone.